Hello.
Hello.
Yeah. Can you hear me?
Yes.
Is Noah also joining?
Yeah, he's coming now.
Okay. We'll continue with divisors and questions on divisors. So, a few questions we'll discuss in today's class. I'll write it down. Let A and B be integers where A is greater than B is greater than 1 and B is the greatest proper divisor of A. Prove that A plus B is not a power of 2.
What would a proper divisor be?
What?
What would a proper divisor be? I
Wait,
guess.
I couldn't hear you. What are you saying?
What's the proper divisor?
Proper divisor means divisor smaller than a number
Oh, okay.
because divisors can be anything including the number itself.
Yeah.
So if you exclude that divisor, then all the other divisors are proper divisors.
Hmm.
Okay. Then the next question is Petya found the sum of all odd divisors of some even number, including 1. And Vasya found the sum of all even divisors, including the number itself. Can the product of the two numbers found by Petya and Vasya be a perfect square? So basically, Petya and Vasya found two numbers. The description is there. Can the product of them be a perfect square? Try these two. Any progress on first one?
Yeah, I think I
Uh,
moved the first one.
Tell me how.
yeah.
So if you let A equal to B times K, where K is a prime number,
Mm-hmm.
then assuming for contradiction that
Wait 1
A,
second. You are saying A is equal to B times K.
Yeah.
yeah,
Why? Oh, B
because
is the greatest positive divisor of A.
yeah,
Okay, so A is equal to B times K. Fine.
then you assume for contradiction that A plus B is equal to 2 to the x, and x is an integer. Then you can substitute in BK plus B is equal to 2 to the x, and you
Mm-hmm.
get B times K plus 1 is equal to 2 to the x.
Mm-hmm.
So now both B and K plus 1 must be powers of 2.
Mm-hmm.
And if K is greater than or equal to 3, there
Mm-hmm.
would be a factor which is B divided by 2 times K, which will be a proper divisor of A and will be bigger than B, which can't be correct because B must be the greatest possible divisor.
Mm-hmm.
And then if K equals 2, K plus 1 will equal to 3, which is not a power of 2.
Mm-hmm.
And, oh wait, it's actually K equals 1. If K equals 1, A equals B, which doesn't work because A is greater than B. And therefore, there cannot be, that's pretty much like a contradiction since K doesn't have any values.
Mm-hmm.
And therefore, A plus B cannot equal to 2 to the power of X.
Okay, you are more or less correct.
Mhm.
Another way to think of it, a slightly different way, is you can say that you can take two cases. One is A is even. If A is even, then greatest positive proper divisor of A will be what? Think about it. And
So all the prime factors besides, oh, it'll be A over 2.
uh,
A over 2.
it will be A over 2. That is the greatest proper divisor of A, right?
Yes,
So then that means in that case, B is equal to A over 2, right?
yes,
Or 2B is equal to A,
yes,
correct?
yes,
Yes.
So then A plus B is equal to 3B, right?
yes.
And 3B is divisible by 3.
Oh, yeah.
So it cannot be a power of 2, right?
Yeah,
Because it has a prime factor of 3 also in it,
yeah,
right?
yeah,
So that is the case for A is even. If A is odd, in that case, the greatest proper divisor of A will be some A over K, where K is greater than or equal to 3, right?
yes,
Because 2 is not a divisor, so A by 2 is not a proper divisor, right?
yeah,
So
Yeah.
then in that case, A plus B is equal to K plus 1 into B, right? And
yeah.
then the logic that you were saying is working,
Oh,
right?
yes,
So
yeah,
A plus B is equal to K plus 1 into B. Now K plus 1 has to be greater than or equal to 4, right?
yeah,
So this number, the sum, 1 second. Basically, B was A by K, right? Yeah, B was equal to A by K. So A was equal to BK.
Mhm.
So we are getting that A plus B has an odd divisor greater than 1, which is B, right?
yeah,
A plus B is equal to K plus 1 into B. So A plus B has a divisor B, right?
Yes.
And B is supposed to be greater than 1, right?
Yes.
And B is supposed to be an odd divisor since A is also odd, right?
Yes.
So odd divisor greater than 1, that means it's not a power of 2,
Oh, yeah. Yeah.
right? Because
Yeah.
B is odd and greater than 1. It cannot be a power of 2 then, right?
Yeah. Yeah.
So that means again you are getting a contradiction. It cannot be a power of 2. In both
Yes.
the cases you are getting for odd and even. Even case is quite easy. Odd case you have to think a little bit. Okay, let's try the second one then.
Oh, question two, I think I solved it.
What is your answer?
Uh, it cannot be.
Okay, why? Tell me.
So if you call the sum of all the odd divisors S,
Hmm.
you have pretty much the way to get the even divisors would be to have 2 times S plus 4 times S plus 8 times S, so on. So then you can say that Utica Vasya will have 2S plus 4S plus
How do you
8S.
know that sum of all even divisors will be like that 2 times S plus 4 times S?
Oh, um,
You are saying this.
because for every even divisor,
Hmm.
it'll be an odd divisor multiplied by some even number.
Right. Okay.
And
Some
then,
power of 2.
yeah,
Basically,
so
what you are
then,
saying is that if the number is, let's say, m, then let's say m has in its prime factorization the highest power of 2 is n. And after that, it can have other prime numbers, right?
yes,
We don't care about the other prime numbers so much. We know that they are all odd.
yeah,
So if you think of odd divisors of this, odd divisors will be combinations of these odd numbers, right?
Yes.
And you're calling them, like, combinations can be done in many ways, but we don't care about how they are doing it. We are
Yeah.
calling these
Yeah.
divisors as adding up to S.
Yes.
But when you construct even divisors, you can make even divisors by multiplying each of these divisors by 1, 2, right?
Yeah.
Or you can do it by multiplying it by two twos.
Yeah.
And similarly till power n, right?
Yes.
So basically the addition of all of these sequence or divisors, like literally list down all the odd divisors, multiply each of them by 2, that gives you even divisors, one row, right?
Yeah.
That is 2s, this is
Yeah.
4s, like that you'll get 8s and so on,
Yeah.
right? And this will
Yeah.
go up to 2 power ns,
Yes.
correct?
Yeah.
So basically sum of these divisors is s common 2 plus 2 squared till 2 power n.
Yeah.
Now what is your next step?
So then, uh, when you multiply them together, you'll
Hmm.
have s squared times 2 plus 2 squared. Oh,
Hmm.
s, yeah, exactly that. S squared times 2 plus 2 squared of course continue.
Hmm.
And if you want the whole product to be a square, since
Hmm.
s squared is a square, you want just that other term to be a square.
Hmm. So
Uh, I,
this sum is a GP sum, geometric progression,
oh,
right?
yes,
You can
yes,
actually calculate it. So it will be 2 and number of terms is n. So a common ratio is also n. So 2 power n minus 1 by 2 minus 1, right?
yeah,
So this is actually 2 power n plus 1 minus 2,
yes,
right?
yes,
Now, most of the times, if you look at it modulo 4, you should be able to answer it. So for example, if n is 1, it is 2 square minus 2. So it is plus 2 mod 4, right?
yes,
And if n is higher than 1, then this term is anyway divisible by 4,
yeah,
right? So it is still minus 2 mod 4.
yes,
So modulo 4, this number is always plus 2 mod 4, right?
yeah.
Is it possible to be a perfect square being plus 2 mod 4?
No.
What are the possibilities that are allowed?
Uh,
For a perfect square, this was the
And
previous
oh, it's only 0 and 1. Okay. 0
only
and 1
0 and
constant.
1 mod 4.
Yeah,
Are you understanding?
yes,
yeah.
So here 2 mod 4 is coming, so this cannot be a perfect square,
yeah,
right?
yes,
Yeah.
So therefore, the answer is no.
Yeah.
Both the questions, by the way, are Olympiad questions only. One of them was Polish Junior Maths Olympiad, the other one is Moscow Maths Olympiad. All of these questions are somewhere they have been asked. So try question number 3 now. Is there a positive integer that has an odd number of even positive divisors and an even number of odd positive divisors? similar to the previous problem a little bit. So think along those lines only.
Yeah. Oh, yeah. Wait, no, never mind. Wait. Yeah, I'll get that there's no positive integer.
Why no?
So if you add up the number of divisors,
Mm-hmm.
odd number, you'll get a total of odd number, which means the number has to be a square number.
Odd number of total divisors.
Yeah, so it'll have to be a square number,
Mm-hmm.
and that means that the power of 2 is even.
Mm-hmm.
So then uh, you can group, so all the even divide, so pretty much for any even divide, which is let's say 2 to the k times some odd number, then since it's even, you can group them up into pairs 2 to the k and 2 to the k plus 1 of the same divisors.
Wait 1 second. Say again. Power of 2 is even. So then what?
So pretty much for every divisor or divisor,
For every odd divisor.
wait, so pretty much every even divisor, which is 2 to the k plus
Mm-hmm.
1 times an odd number, there will be an even number 2 to the k times the same odd number. And since the power of 2 is even, there will always you will always be able to group the even divisors in this way.
So for example, let's say power of 2 is even. Power of 2 was 4. What are you saying?
So pretty much you'll group up all the factors with 2
Mm.
to the 1 and 2 to the 2. And then 2 to the 3s with 2 to the 4. And with each of the other odd numbers, and then that way there'll always be an even number of even divisors.
You are saying there is a grouping of the
Yeah,
even divisors.
you can always group the even divisors into pairs.
Um, because you're saying number of, see, even divise, suppose the odd divisors are listed.
Yes.
All the odd divisors are listed like this, right?
Yeah.
For each odd divisor, you can multiply by power of 2 and you will get one full row of even divisors like this, right?
Yes.
And similarly, 2 square until 2 power 4, right?
Yeah.
Is there any other possibility of getting an even divisor? No, right?
No.
So that means there is an issue because if this total number of these divisors was odd, there was how many odd divisors? There were even number of odd divisors, right?
It doesn't matter how many odd
No, what I'm
divisors.
saying is every odd divisor can be converted to an even divisor.
Yes.
So both have to have same parity.
Yes.
But in the question, they are saying odd number and even number, right?
Oh, yes.
Yeah.
Do you understand what I'm saying?
Yeah.
Yeah.
Like, no matter how many odd divisors are there, like if any number you take, whatever it is, 2 power 3, P1, P2, P3, odd divisor only come from here, right?
Yes.
So you can say 1. The question is asking positive odd divisors. Okay, so 1, P1, P2, and so on. And you can, for each of for 1, you can multiply with all the powers of 3, right?
Yeah.
This is a list of 1 at a time divisors. Then there will be a list of 1 times P1. Okay, but that is matching. Okay, maybe this is not perfect because of the 1. 1 second. Okay, so let me just think of it in a different way. Let n is a number, given number. If n has odd number of even positive divisors, then the number of even positive divisors must be greater than equal to 1, right?
Yeah.
So that automatically, because it is odd number, so odd number starts with 1, right?
Yeah.
Correct?
Yes.
So at least
Yeah.
1 even divisor it has, right?
Yeah.
It could be 3 or 5 or 7 also, right?
Yeah.
But at least 1 even divisor it has, right?
Yes.
So doesn't that automatically mean that n itself is even,
Yes.
right?
Yes.
Now, the d of n was what? Number of divisors of n. In
Yeah.
this question, because of the way they have said it, d of n is odd, right?
Yes.
Because even plus odd number of divisors is going to be odd number of total divisors, right?
Mhm. Yes.
If d of n is odd, we are getting n is a perfect square,
Yes.
right?
Yes.
Number of divisors is odd means n is a perfect square, right?
Yes.
So n should be something like this: 2 to the power 2k, p1 to the power 2 alpha 1, p2 to the power 2 alpha 2, and so on, right?
Yeah.
Correct?
Yes.
So now for this situation, this number of odd positive divisors of n. Let's actually calculate the odd divisors. You have to exclude the 2 powers, right?
Yeah.
So it should be 2 alpha 1 plus 1, 2 alpha 2 plus 1, right?
Yes.
And 2 alpha k plus 1, right?
Yes.
Does everyone understand why d of this n should be only odd?
Oh,
Yeah.
yeah.
I am excluding the 2 powers. I am saying
Yeah.
that P1 can be given 2 alpha 1 plus 1 ways you can select it or not select it, right?
Yeah.
Either you don't include it or you include it in 2 alpha 1 ways.
Yes.
So this number is clearly odd, right?
Yeah.
So now it's a contradiction because this was supposed to be even.
Yes.
That is one way to do it. Uh, yeah. The other way to do it is the way that I was trying to do earlier, where you can say that if 2 power k is largest power of 2, largest power of 2 that divides this integer, then each divisor each divisor can be written as, similar to what we did earlier, can be written as 2 power m into n, where m is from 1 to k, right?
Yeah.
And n is odd. N is odd.
Yeah.
So basically, each divisor can be written like this. Each even divisor, I mean, right?
Yeah.
Yeah.
So from each n, which is an odd divisor, from every n, which is an odd divisor, I can make so many even divisors, right?
Oh.
Yeah.
Yeah.
So notice that these are all even divisors, right? And there are k different even divisors, right?
Yeah.
That have come from one single odd divisor, right?
Yeah.
Correct? So
Yes.
if there are n, if there is some number of odd divisors is whatever, let's call it p, which is the number of odd divisors.
Yeah.
Then you should get
Yeah.
kp number of even divisors, right?
Yes.
Yeah.
So if this number is even,
Oh yeah.
then this is also supposed to be even, right?
Yeah.
Yes.
But the question is saying that that is odd.
Uh,
So there are many ways to do it. This is the second way. The first way is a direct count we did after we realized that n had to be perfect square, right?
Yeah.
N had to be perfect square because the number of divisors of it was basically, it has at least one even divisors, which means that the n itself is even, right?
Yeah.
And because n was even and dn is odd, total number of divisors is odd, the n is a perfect square. And then we did an actual count in that case, right?
Yeah.
This is the alternative approach where you're connecting the odd divisors to even divisors. And you can construct from every odd divisor, you can make so many even divisors. Correct?
Yeah.
yeah.
Okay. So this is a proof question where you have to basically figure out that where the arithmetic mean of all of these divisors will lie.
Okay.
All of the divisors of a number n lies in this interval we have to prove.
Oh, wait.
So I want you guys to write down these three questions, 4, 5, and 6.
Okay.
Okay.
These three questions you need to try. Sunday we'll be discussing this and a few more questions, and then this topic will be over.
Hmm.
There's not too many left, but we need to just finish up. Like maybe there are like 5, 6 more questions. So these three and a few more.
Hmm.
Write it down and try it till Sunday,
Okay.
and we can discuss this. For the fourth one, you should try to prove that the arithmetic mean is bigger than this and smaller than this. It's like an inequality problem.
Yeah.
By the way, the arithmetic mean of divisors is like saying, in this case, is like saying sigma n by k, where k is the number of divisors, right?
Yeah.
Oh, yeah.
Remember,
Yeah.
sigma n was the sum of the divisors function.
Yes.
Sigma n, d of n, those are functions which are multiplicative, which we saw that in the first class.
Yes.
So we need to somehow prove that this thing lies between these two values.
Yeah.
So try it out and write down 5 and 6 also.
Yeah.
Yeah.
Have you written it down?
Yeah.
Both of them, 5 and 6?
Yes.
Okay. So basically, there are three topics left in our plan for number theory. After this, divisors. Divisors will maximum take 1 or 2 more classes. After that, we have to do one chapter is I want to do number basis. Number basis. Then another topic of factorials. And finally, games. Games means sometimes there are questions where there is a game type of situation where two players are playing and there is some rules, right?
Yeah.
So those types of questions, like the ones that are related to number theory. So these are the three topics that I want to cover. Again, every topic will have like some 10, 12 problems that we'll discuss.
Yeah.
And there are some few techniques that you need to know. If you are making notes of whatever we have done, it will be useful for you because these techniques are very common. The reason we
Yeah.
are doing some 10, 12 problems and all is because those techniques will be used again and again.
Yeah.
So for the previous things that we discussed before divisors, we were doing prime numbers and all, right?
Yeah.
So make sure that you remember perfect squares and perfect cubes we did, right?
Yes.
So make sure that you go through that. If you're writing an exam or all, preparing for an exam, you need to go through all that.
Okay.
The type of questions we saw, the techniques we learned. We will do like once we finish with this, we'll move on to different topics and we can come back to number theory later when your exams is closer. We'll do a revision later, but for now, this is the plan.
Yeah.
So these three topics, mostly we should be done with it in like each topic, you can say 2 to 3 classes. So it will take around 8, 9 classes to finish it.
Yeah.
Yeah.
So next class, I want to finish divisors. So try the questions and then we can see how much is left.
Okay.
Okay.
Yeah.
And make a plan for, okay, what you need to discuss. Is it geometry or do you want to do algebra or what? Combinatorics.
Oh,
Figure out what you need urgently. So we'll do accordingly.
yeah.
After number theory, what you need to do, that accordingly we'll plan out and do. Okay, fine. That's all for now then.
Okay. Thank you.
Hmm.
Okay. Thank you.
Bye.